All right, so let's go ahead and look at these rules that we learned back in other previous classes before AP Calculus. So here we already know you should remember how to change the log function to exponential, changing logs to exponential, exponential to log. And so here, just seeing how b and c become the base and the exponent, and it's equal to a. So you should be able to go back and forth between those, which will be helpful later on when we do our work. You should be able to do change of base when it comes to your log. So you should be able to have log a base b here, and you should be able to make it as log a over log b, both having base 10 to make it easier. You can put that in the calculator and actually find the answer quicker that way because the calculator only understands base 10. Or you can do natural log of both a and b here, and you'll get the same answer here. So you can do change of base, making it base 10 on both of those because that's what the calculator understands, or natural log. And then here are the rules that you've learned, hopefully. So this was the product rule. So if you have two functions together, you can multiply, or two functions together, you can go ahead and give the m-log, n-log, and then add addition in the middle. That's your product rule. Your quotient rule was you give the m-log, n-log, and you change division to subtraction. So m got a log, n got a log, and put subtraction in the middle. That was your quotient rule. And then power rule here was the last one. And that means all you do is take the exponent and move it in front, and you get k log m base 6, b. So here, whatever the exponent is, you just move that in front. And that's what they did there. Your product rule. So all those, hopefully you remember those. If not, quiz yourself on them until you know them, because they'll be really helpful for this log function and log portion of this derivatives. All right, so it says use the properties of logarithms to rewrite the function and then find the derivative of this function here. So logarithmic functions, you can change it over. You can do a couple of things here. You can make it into the fraction and do quotient rule. You can change it so that you're dealing with exponential function. There's a bunch of ways of doing this. Let me do it because I want to come back and do the quotient rule because we haven't done that for a little bit. So don't want you to forget that part. So I'm going to come back and I'm going to make this. Well, first off, everybody hopefully remembers how this radical changes to a fraction exponent. So we know square root of x is understood at 2 right there because it's square root. It's understood 1 here because there's no number there. So that means our fraction would be 1/2. So here with this part here, we'll go ahead and go y equals 5x to the 1/2 power. Now with this, we can go ahead and do a couple of things here. Let's see what I do. What did I do? Yeah. I'm doing the quotient rule because this takes us back to what we talked about with the log that we just learned up here in the last video earlier on this page. So I'm going to do change of base. So I'm changing it to the natural log though at this function. Now, as a quick reminder, natural log 5 is a actual number. So whenever you find the derivative of it, it's going to be 0 because it's actually a number itself. And we're going to talk about that when we get to our quotient rule. So we're going to end up using quotient rule here. And really, we don't even have to use quotient rule. All we have to do is just, if we want to, because this can be considered a coefficient, so we can rewrite this so that's 1 over natural log 5 times the natural log of x to the 1/2 power. And again, if you put that in the calculator, that's a number. And because it's a number, it's a coefficient, therefore you can move it in front and just deal with this portion here. So when we take our derivative here, we're going to take derivative of just this portion. So we're going to keep 1 over natural log 5. And we're going to do derivative of natural log x to the 1/2 power. And here, we just talked about it up earlier. This is considered your u. So we'll go ahead and make that u and then go from there. So we'll keep the 1 over 1 natural log 5 here. Keep that portion. And then here, this would be ln, sorry, 1 over, sorry, my fault. Let's do this. I want to make sure I do this also. Natural log u, and then u is actually x to the 1/2 power. That part, I want to do that part here, so that when we come here, we know that's 1 over u times u prime. And then here, the derivative of that was 1 over u, and then the derivative of this is 1/2 x to negative 1/2 power. And so we substitute the values in. That's 1 over natural log 5. Sorry. And that's going to be 1 over natural log x to the 1/2. Sorry, u, sorry. My fault, guys, sorry. 1 over x to the 1/2 power times 1/2 x to negative 1/2 power. And again, you can leave it like that, but we like to, as mathematicians and stuff, it's best to, we like seeing simple stuff, not actually like messy and nasty and everything. So let's go ahead and do that part. Let's simplify it down. I'm going to do that over here on this side because I ran out of space over here. Well, there might be enough space here. Let's try it out. And so here that will bring it down. So we will have 1 over x to the 1/2 power times 1 over 2x to the 1/2 power. All right, remember when we multiply here, we just add the exponents. So here, this would be 1 over natural log 5. So that would give us 1 over 2x. Because again, we multiply, we add the exponents. So 1/2 plus 1/2 is 1. So therefore, it's that 1 right there. Then this final answer, simplify it down, is 1 over 2x natural log 5. So that is your final simplified answer right there. Okay, cool. So that gave us that part. So those are using rules that we have. But we're going to have one more video that we're going to finish up everything on.